Hello students, in this session we will again discuss the screening effect as we have discussed earlier or in previous video about the shielding effect. What is the shielding effect as we have already discussed in the previous video. In nutshell, we can say that when the shielding effect or screening effect poor, so size of atom increases, then the screening effect strong, so the size of atom decreases. When the screening effect is strong, the size of atom increases. So I think you have well understand about the shielding effect or screening effect and what is the impact of shielding effect in D block contraction. So we all know about the name lengthened contraction. So see here, I am going to explain the D block contraction. Try to understand D block because it is used in this contraction. D block contraction. D block or P block, as at first, suppose we write the second period. There is the boron in third period, aluminum in fourth period. In fourth period, after aluminum comes gallium. In fifth period it comes indium, and in sixth period it comes thallium. So at first in P block elements, on moving from third to fourth period. Students, as we know, second period only S and P electrons. In third period, S and P orbital. In third period also S and P orbital. But in the fourth period, S, P and D orbitals participate in the electronic configuration. So remember it, when we move in third to fourth period, the entrance of D orbital occur. So in P block elements, on moving from third to fourth period, there occur 10 D block elements. 10 D block elements in which the last electron enters in n-1 D subcell. n-1 D subcell. Since the shielding effect or screening effect of D electrons is very poor. The attraction force of the nucleus on the outer electron increases as a result of which size decreases. So try to understand the role of shielding effect. When the d orbital electrons present in d orbital and s orbital, as we know, they do not shield the nuclear charge very much effectively. So the nuclear force of attraction fall onto the outermost electron strongly. In that condition, the size of atom decreases, and this is the result of d block contraction. We know that lengthenoid contraction. What is lengthened contraction? We will study in class 12 in details what is the consequences, but here we should know about the reason for the contraction, because when you write the electronic configuration of lanthanum series or lanthanum, you can see the decreasing of atomic radius. What is the reason for the decreasing of atomic radius? So during electronic configuration, we see the presence of the f orbital, and we know that f orbital electrons are not properly screen the nuclear charge, so the nuclear charge effectively fall onto the outermost electron, and that is the reason for the contraction of lanthanide. Write down the points also. What is lanthanide contraction? On moving from 5th to 6th period, 5th to 6th period, there occur 14 lanthanide element in which last electron enters in n-2 f subshell, n-2 f subshell, since the screening effect, screening power or effect of f electron are very poor, shielding is not effective, therefore obviously the attraction force of the nucleus on the outer electron increases. As a result of which size decreases. This is reason for the lanthanide contraction. Lanthanide contraction operate after group third. You can see the periodic table. Lanthanide contraction. You can write the points also. Lanthanide contraction operate after group third. Both lanthanide and D block contractions are more pronounced in group 13, 14 and get weakens afterwards. Now, we'll discuss about the variation of atomic radii along with period and group. At first, we talk about the period. as we know, on moving from left to right in period, atomic radii increases due to increase in Z effect. It is called the effective nuclear charge. Effective nuclear charge. See here, for example, we talk about the third period. Suppose third period. The third period, the first member is the sodium, and when we move from left to right in 17 group, there is a chlorine. We do not talk about the noble gases because the property of noble gases is different from the group 17 members, and the size of noble gases is also slightly bigger than the group 17 members. This is the group 1 members and this is the group 17 members. Here we can discuss in sodium only 3 energy shell is involved for filling the electron, and when we move from left to right, number of shell remains the same, but the number of protons increases when we move left to right. Here sodium is 11 protons and chlorine has 17 protons. Number of shell remains the same. Electrons enter same shell when we move left to right in a period. So the number of protons increases, and this large number of protons strongly pull the electron towards itself. So we can say that when we move from left to right in a period, effective nuclear charge increases. That is the reason for decreasing the size of element when we move from left to right in a period, because electrons enters in same cell and the number of protons increases. So large number of protons strongly pull the valence electron towards itself, and the size of atom becomes shrink or decreases. Write down the noble gases. About the noble gases. Noble gases have greater atomic radii, due to their full-filled or vital. Full-filled or vital. Or in another way we can explain on the basis of in noble gases there is a big van der Waals force of attraction exists, but in group 17 or halogen family there is a strong chemical bond like covalent force of attraction exists. So when we talk about the size of element across the period, we will never include noble gases because the property of noble gases is different from the group 17 members. Now along a group, variation along group. On moving from top to bottom, from top to bottom, in a group, size will be increases due to addition of new energy shell. So students, see here, if if we talk about the group 1, first member is lithium, sodium, potassium, rubidium, cesium and francium. So we can say that when we move from top to bottom, the number of shell increases. Here is atomic number is 3. So number of shell is K and L. Here is the number of shell K, L, M. Here is the number of shell K, L, M and N. So on. Number of shell, energy shell increases. As PDF, you can write the configuration also. So in this way you can easily calculate, easily find out how the size of atom increases when we move top to bottom in a group. So simply we can explain on the basis of this, on moving from top to bottom, the size will increase due to addition of new energy shell. Another method is diagonal relationship. Diagonal relationship. We know that size increases when we move from left to right in a period, and when we move top to bottom in a group, the size increases. And here is the element have property same, because suppose by example we can lithium, right? Lithium, beryllium, boron, sodium, magnesium, aluminium, potassium. So when we move left to right in a period or top to bottom, the atomic size almost same. So if the atomic size almost same, their property will be also same. So lithium and magnesium both show similar property, because when we move left to right and top to bottom, their size almost equal, almost same. So due to same atomic size, they show the similar chemical property. Beryllium show the property like aluminum, lithium show the property of magnesium. This is the diagonal relationship, and it is found only period 2 and 3, between period 2 and between period 3. Now we will discuss about the isoelectronic spaces. Isoelectronic spaces or ions. We have already read in structure of atom also. Simply we define as isoelectronic spaces may be defined as neutral or ionic spaces of defined as neutral or ionic spaces of different element which have same number of electrons. So the species which have same number of electrons, they are isoelectronic. For example, aluminum, magnesium, sodium, fluorine, oxygen, nitride, so on. If we talk about the increasing order of ionic radius, so we can say that greater the charge, smaller will be the size. So aluminum is smaller than the magnesium magnesium is smaller than the sodium, chlorine and the nitride. Greater the charge on the non-metals, bigger the size of species. But in case of metal, greater the charge, smaller the size. Note down the point also. At first, radius of an ion. At first, radius of an ion. Radius of an ion is always greater than the neutral atom. Radius of an ion is always greater than the neutral atom. Sign greater than oxygen. So it is greater than its neutral atom. Neutral atom. If next point, if different atoms have same number of electrons, then the anion having greater number of proton which is smaller in size. For example, nitrogen 3 minus, oxygen 2 minus and fluorine 1 minus. How many electrons? 10 electrons. How many electrons? 10 electrons. And it has also 10 electrons. And what about the protons? It has 7 protons, it has 8 protons and it has 9 protons. So when we talk about the different atoms have same number of electrons, so size of this is bigger than this and this. We can write if different atoms have same number of electron, than the anion having greater number of protons, is smaller in size, So in this way you can see here which one will be smaller in size. Why chloride ion has smaller size than oxide ion, and why nitride ion is greater size than the oxide or fluoride. So this is about the anion. And about the cation, right also. Radius of cation. Radius of cation. We all know that neutral atom has greater size than ion, because here is the effective nuclear charge and here is the neutral. So first condition about the radius of cation, neutral atom has greater size than the ion. And the second point is if various cations have same number of electron than the cations having greater number of positive charge. Positive charge means nuclear charge. Positive charge means nuclear charge is smaller in size. For example, sodium 1 charge, magnesium 2 charge, aluminum 3 charge. This is the smaller in size because the effective nuclear charge is greater, so that it is the smaller in size. Here is the effective nuclear charge is less. There is also effective nuclear charge less than aluminum, and effective nuclear charge is maximum in aluminum. In comparison to sodium and magnesium. In nutshell, we can say that greater the positive charge, smaller will be the size. So in this way you can find out the given isoelectronic species, which one will have greater in size, either cation or anion. In the next session we will discuss the next property, that is called ionization.